All right, we're going to verify that for all n greater than or equal to 1, this product is equal to this formula. So we're doing proof by principle of mathematical induction. We're going to do our base step. We're going to consider, of course, P of 1. So that's 2. Is it equal to 2 times 1 factorial over 1 factorial? Well, yeah, right? Because it's that checks out because 2 factorial is 2, 2 factorial over 1 factorial is 2, right? So let's go ahead and look at the second one. So consider P of 2. So that's 2 times 6. That's equal to 12. And let's go ahead and see if it works for that formula. So it's 2 times 2 factorial over 2 factorial. That's 4 factorial over 2 factorial, which is, of course, 4 times 3 times 2 factorial over 2 factorial, right? And that gives us 12. So that checks. So let's go ahead and do our induction step. Suppose P of k is true. Thus, we have 2 times, what is it, 2 times 6 times 10 times 14 times 4n minus 2, or 4k minus 2, right? 4k minus 2 is equal to 2k factorial over k factorial, correct? Yes. All right. So let's consider 2 times 6 times 10 times 14 times the 4k minus 2, and then 4 times k plus 1 minus 2. And remember, from our induction step, this product, right, this product here is equal to factorial over k factorial, and then times the 4. So this will be 4k plus 2, right? Because 4k, 4 minus 2 is that. Okay, so this is equal to 2k factorial, and then I can factor out a 2. So I'd be left with 2k plus 1 over k factorial, and then 2k factorial times 2k plus 1, that's the same thing as 2k plus 1 factorial times 2 over k factorial. And remember, what I want is the bottom is k plus 1, right? K plus 1 factorial. So what I'm going to do is I'm going to multiply top and bottom by k plus 1. So I can get my k plus 1 factorial, right? Because k factorial times k plus 1 is what I want, k plus 1 factorial. And then I have 2k plus 1 factorial times 2k plus 2. And that's exactly what I need, right? This is equal to 2k plus 2 factorial over k plus 1 factorial, or 2 times k plus 1 factorial over k plus 1 factorial, right? That's what I want. Yeah. So thus, I was able to show that 2 times 6, right? Yeah, 2 times 6 times 10 times 14, dot, 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 4k minus 2 times 4k plus 1 minus 2 is equal to the 2 times k plus 1 factorial over k plus 1 factorial. Therefore, by PMI, for every n that's a positive integer, right? I know 2 times 6 times 10 times 14, dot, 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 times 4n minus 2 is equal to 2n factorial over n factorial. And that is my proof, right?